Those of you familiar with the film Interstellar may remember the black hole that plays such a large role in the storyline, Gargantua. But what is Gargantua? Just a writer conjured up black hole to fit their storyline? Or is it based on a black hole that's really out there? Let's have a look. For those of you that don't know, Interstellar was a 2014 created film around space travel, more specifically space travel in a future where our planet, Earth, becomes inhabitable and the human race is forced to look out into the stars for a new home. This search leads the characters on an expedition through a nearby wormhole to look at two potential habitable planets. These planets happen to orbit a black hole, Gargantua. So it's kind of an initial answer to our question. Gargantua is a hypothetical black hole, but the science for its existence does seem to check out. According to calculations done in a book called The Science of Interstellar by Kip Thorpe, Gargantua is estimated to lie at around 100 million solar masses, so its mass is 100 million times the mass of the Sun. According to the classification of black holes, a supermassive black hole would have a solar mass of hundreds of thousands to billions of times the mass of the Sun, so Gargantua would be pretty comfortably a supermassive black hole. It's presumed Gargantua would be near to or at the centre of its residual galaxy. It may even be the supermassive black hole of its galaxy, as we know from observation of our universe that nearly every large galaxy appears to contain a supermassive black hole at its centre. So, despite the science checking out for Gargantua's existence, its representation in the film was not wholly accurate. It was toned down a bit. In reality, the images of Gargantua's event horizon would have shown it as being very warped and both red and blue shifted, but obviously this didn't suit the movie. There's also another question here. In Interstellar, habitable planets orbit Gargantua, but is this possible? Could a habitable planet not orbit a star but get its light and energy from a black hole? Well, it seems it's an interesting enough question to ask, as some scientists actually underwent a study of this exact thing inspired by Interstellar itself. Named scientist astrophysicist Pavel Bacala of Silesian University and his colleagues explored this situation. So, for life to evolve on a planet, it needs two things: a source of energy and a heat sink for waste heat. On Earth, we have the sun for energy, and space, it acts as our heat sink. In the case of an arrangement similar to in Interstellar, this would have to be exactly the opposite. The black hole would function as the heat sink, with energy provided from cosmic microwave background radiation that has been squeezed by the huge gravity of the black hole into a narrow beam. This beam would appear as a bright star on the edge of the black hole's shadow if you were looking up from an orbiting planet. So far, so good. However, to receive strong enough light, a planet would need to orbit very close to the event horizon. This is possible if the black hole is spinning fast enough. Less than 100 millionth shy of the speed of light should just about do it. But obviously there's no way to speed up a black hole, and there's some uncertainty around a black hole could ever get up to these speeds. The black hole would also need to be 163 million solar masses, according to the researchers' calculations. This would be quite a bit larger than the estimation for Gargantua earlier. The reason for this is because larger black holes do not disrupt nearby planets with tidal forces until that planet is inside the event horizon. Then we have to consider the area surrounding the black hole. This would need to be almost empty, as any matter being sucked into the black hole would cause a blast of radiation that would kill life on any nearby planet. And finally, due to the time dilation effects mentioned in Einstein's theory of general relativity, each year on an orbiting planet around this hypothetical black hole would be equal to thousands of years orbiting around a normal star. So, to answer this question, yes, it's possible a habitable planet could orbit a black hole, at least it seems so, but it's quite unlikely.